Now we did great on that last example, but I think it's important that we go through just one more so that we make sure that we're following the same steps every time we have the equation in standard form. I went ahead and wrote steps out here so that we can make sure that that's exactly what we're doing as we're going through the problem, because that's just going to make it easier for us, and we love easy. So, the first thing we need to do before we even look at the steps is we want to go ahead and identify what our A, B, and C are so that it's way easier once we get going. So, it's easy to see that our A is 1/4 because that is the coefficient before the x squared. So for A, we have 1/4. It's also very easy to see that our C is going to be a -3 because that's the coefficient standing alone. But we're going to have a little bit more trouble seeing what our B is because there's really nothing there. But if there's nothing there, can't we just write that this equation is actually 1/4 x squared plus 0x minus 3? By doing this, we're not adding anything to our equation. All we're doing is adding a 0, but we're putting it in the standard form that we like. That way, we can see that our B is 0. Now that we have what our A, B, and C are, we can go ahead and start working through the problem. So, our step number 1 is to find the y-intercept, and we remember that C gives us our y-intercept. So we're going to write this in the form of 0, C or 0, -3. Now, since we know that for sure is a point on our function, we're going to go ahead and graph it. So I'm going to go to 0 in the x and go down -3. 1, 2, 3. So we already have 1 point for us. Now our next step is to find the axis of symmetry. And we remember that the axis of symmetry is found by the equation x equals -b over 2a. So we have our b and we have our a. Now what we're going to notice is when we plug this in, we're going to get x equals 0 over 2 times 1/4, which is 1/2. Now we know that when you divide 0 by anything, you're left with just 0. So x equals 0 is our axis of symmetry. So we can go ahead and plot that. You're not going to be able to see it very well because it's actually on the y-axis, but just for purposes of practicing, we know that our axis of symmetry is right there on 0. Now next, we have to find our 5-point table, and our 5-point table is going to center around that vertex, and we know that the x-coordinate of the vertex is found on the axis of symmetry, so that means the x-coordinate of the vertex is going to be 0. So we're going to create our table around that. So we're going to create a table, x and y, with 5 points, and our center point is going to be when x is 0. Now because this equation involves a fraction, I'm going to go with even numbers so that it's easier to work with. So I'm going to go forward 2 each time, so I'll have 0, 2, and 4, and then I'm going to go backwards 2. So I'll have -2 and -4. Now I have to take those points and plug them into my original equation so that I can get the y points for them. We'll go through a few of these together and then I'll just fill in the rest. So the first one, we're plugging in -4 here. So we get -4 squared, which is 16, times 1/4. So this first thing we have is 4. Then we have plus 0 times -4, which is just plus 0, and then -3. So our y is equal to 4 minus 3, so our y is equal to 1 when x is -4. Now you're going to do the same thing for the rest of these points, and you're going to come up with -2, -2, 0, -3, 2, -2, and 4, 1. Now we have those 5 points, and our next step is to graph and label. Now, what are we going to label? We're going to label our vertex, and we know that our vertex is right here at 0, -3, because it lies on our axis of symmetry. So we're going to go ahead and graph. Now I'm just going to connect these with a parabola, And there we have the graph of y equals 1/4 x squared plus 0x minus 3. The last thing we have to do is we have to go ahead and label our vertex so that everyone knows where we're starting. And we have that at 0, -3. And look at there, you have graphed another quadratic equation. Now there's one last thing that we have to talk about, and that is about finding the maximum or minimum point on a parabola. Does it make sense to you that if we have here a happy parabola, that our minimum point is going to be right here at the vertex? Because that is the lowest point on our parabola. And over here on our sad parabola, our maximum point is right here on this vertex. That means that no matter what, your vertex is always either your maximum or minimum point. It also means that if you have a happy parabola, you have a minimum point. And if you have a sad parabola, you have a maximum point. That seems easy enough. But what's going to happen is they're not going to give you the picture. They're going to give you this equation, and you're supposed to determine what the point is without graphing it. So what we have to do is we have to look at this equation, figure out what our A is, which will tell us which way our parabola opens, if we have a maximum or minimum, and then we can find the point. So let's look at this first example. Y equals -2x squared plus 4x plus 3. That means that our A in this case is -2. Now, is that going to give us a happy parabola or a sad parabola? Well, A is negative, which means we're sad, so we're opening down. Now, since we're opening down, we're a sad parabola. That means that our highest point, our vertex, is going to be the maximum. Now that we know we have a maximum point, we can write that we're looking for a maximum. So we're looking for a maximum point, and that maximum point is going to be the y-coordinate of our vertex. So we have to start finding our vertex. How we do that is, if you remember, we find the axis of symmetry, which will give us our x-coordinate of the vertex. Then we're going to plug that into our original equation to find y. So in this case, our axis of symmetry, x equals -b/2a, is going to be x equals -4 over 2 times -2, which means x equals -4 over -4, or x equals 1. So our x-coordinate in this case is 1. Now we need to plug that in to find out what our y-coordinate is. So we plug it in, and we have y equals -2 times 1 squared plus 4 times 1 plus 3, which means y is equal to -2 plus 4 plus 3, so y is equal to 5. So once we've done that, we have found the y-coordinate of our vertex, so that means we have found the maximum point for this equation. Now that seems easy. Just remember, if this had been a +2, we would be looking at a happy graph, so we were looking to find the minimum point, and we would follow these same steps. We would just come up with a minimum point. So all you have to do is determine if your A is negative or positive, then take that, determine if you open up or down, means you need a maximum or a minimum. You find the y-coordinate of your vertex, and you have found that point.